Alright, take two. So, you're new to CAD and you want to get started. Well, I guess this could be your first video. What is CAD? Well, it stands for computer aided design. It's what allows people who might not be as good as drawing, like myself, to be able to create whatever we have on our mind and see them through to production. Or at least have a proof of concept. It's a place where you can take your ideas from your mind and generate them into a 3D visual representation of what you're trying to communicate to your teammates. You could also take that further and make it more refined to the point where you are able to 3D print it and make a 3D mock-up in real life, whether it be a finished, high-end fidelity prototype or a low-end, quick and dirty model. It doesn't even have to be functional. It could just be visually correct. So there's a lot that goes into CADing. Most of the background comes from industrial design, I believe, with sketching, hand sketching, and being able to draft what you want. In the past, they didn't have computers, so what they did instead is they had to draw everything with projections, or they had to take an object and project its faces. So the most amount of information can be represented, like the measurements of certain things from a certain angle would be taken to then be able to, it would be described onto a piece of paper so that someone else that has that piece of paper can recreate that same model that you took those dimensions or measurements from and remake it. That is what might be called a blueprint. There's no official technical terms I'm going to be using. I'm just kind of making these as I go, so just keep that in mind. So for this semester, at least for the club, we're going to be using robotics. We're going to be using Fusion 360, which is a Autodesk product. If you've used SolidWorks or Onshape or Inventor, those are all great prior experiences. However, this video will be more of an in-depth, slow-paced kind of introductory for those who are getting started. So Fusion 360 is really nice in my opinion, as it has a bunch of features. You can design things, you can ask the computer to design for you if you want to see what organic shapes it can come up with. It's pretty cool. If you want to render things to make them look pretty and put them on posters or presentations, you can. If you want to animate assembly or a group of pieces that make up a compound object, let's say a keyboard, it has all those little buttons on it, it has the frame that's sitting on it, it has the cable that runs the computer. You can animate each of those to represent what you want to showcase in your storyboard. You can simulate things, so if you want to test what you've made to see if it can undergo the forces that you're trying to put them through, let's say a bracket, which is something that holds one thing at an angle to another, then you might want to see if that's capable of holding that without breaking. There's a lot of different simulations. However, it's called static stress simulations, and they're pretty useful sometimes, and they can be fun to try and experiment with. Manufacturing tab is kind of one of Fusion 360's greatest weapons against other CAD programs, because it is one of the most developed CAM softwares, even against SolidWorks. It has drawings, so you can take these drawings. If you make something in three-dimensional space, we need to be able to put them on that flat piece of paper, and put the measurements on it, so that someone else can look at that and recreate what you have. Okay, so those are the environments. On the left side, we have our data panel. You can hide the data panel by this 3x3 grid matrix looking thingy in the top left. When you start off with Fusion 360 and you have an educational license, it'll probably ask you to make a team. Just be careful when you make this team name, because this team name won't be able to be changed. And when I first started off, I named it Embrace because that was a team I started. So things have changed and time has passed, and it's not always going to be Embrace for all the school projects I've done. So just be careful with what you name it. Make it something general, because educational account gives you access to a couple cool tools that you might want to use for other classes. So just to make it less confusing for when you share your project with other people. They won't ask, why is it named Embrace? Just name it something general. Okay, this is your data panel. It's just like any other file explorer. You can make folders within folders within folders and folders, and you can make files within those folders of the folder of the folder. You can name things, you can move things around, you can just right click to have a lot of different options. So if I come into here, like for example, let's say I want to move this file, I can open it, I can insert into this current design, so I can just pull this exact model into here. I can make a new drawing from the design. I can share a public link, so everything is on the cloud. As long as you give Fusion the go-ahead to publish a URL, then people can open that URL and you can control if they can download it or just view it. It's pretty nice to have it on the cloud, as people can download it in whatever format they want. They can leave notes on there, they can view it in 3D in a 3D viewer, and stuff like that. So let's go and start with making a new project. I'm gonna name this training med robo. So I have a lot of different files, and I'd like to keep this one kind of up there so I can keep track of it, so I can pin it. Oops, yep, I can pin it. So training med robo. Now I have a folder, and inside the folder I can put a new file. Your interface will look a little different because I've customized mine. You might have a grid, and your background environment may be more white. However, I will keep it, oh, that's too dark. I'll keep it to what I like, which is an infinity pool with no grid, and you can change that however you'd like. On the bottom, let's cover some more UI elements. Let me hide the data panel now that we understand how the data panel works. On the bottom, you have a timeline. This is how you do parametric modeling. Parametric modeling is that if you design everything with specific lengths and widths, you can later come back, change one, and everything that you've done to that one block will update so that it doesn't fall off the piece. If this will make more sense as we go. But if I put a circle at the corner of that rectangle, and I later change the rectangle to have a higher height, the circle would then just it would stay attached to that corner, and it wouldn't just stay in that position of the original height. That is what parametric modeling is that it would snap to the corner and stay there no matter what height I make it. So this is our workspace. This is where we manipulate our 3D view. You can click and drag in the view cube on the top right to orientate yourself. The pivot point is showcased in the middle. If you middle mouse and shift together, you get the orbit, and you can see the orbit location is the green dot here. You can also orbit with the tools down here, so you can orbit like so, or you can grab this ring here and rotate like so. You can push look at. This is useful when we actually have something to click on to look at. Pan is this hand tool. Zoom is to zoom in and out, but you zoom in and out is also your scroll wheel. Pan is also middle mouse drag, and you have a bunch of display options. On the top here we have a ribbon with ribbon bar with the drop down menus. We have different ribbons. We have the solid ribbon, surface, mesh, sheet metal, plastic, and utilities. I may have a couple more add-ons than you guys because I've been using this for quite a bit more time, but you're able to add on anything you'd like as long as it's been pre-programmed on the internet. For example, this Veroni sketch generator might not be something you have, but you can add it for yourself later. And this add-on just lets me make cool geometries that are organic, that I can 3D print out, that are really complicated. So solids, they kind of are what you kind of CAD with mostly. You get a 2D surface and you can pull it into three-dimensional space. You start with 2 dimensions and you pull it into the 3rd dimension, and you start adding and cutting away more to make more complicated surfaces. Okay, let's finish off. So let's go ahead and save this file to training med robo. I can select specifically where I want to. I can select inside another folder within a folder, or I can put inside my training folder. I'm gonna be like first part. I'll save it. Name here, it says V0, so every single time I save, it'll tick up 1. And you can access the versions here later. It saves the time, the date, how long you've been working on it, how many versions you've been through, and if you want to revert, you can revert back to. It also shows you where it's been used. It uses certain, if you pull in other CAD models, you know, if I make part 2, part 3, and I pull them into part 1, then I'll show you part 3, part 2. If it's been used in others, for example, if I put part 1 in part 2, then in part 1, like underneath it, it'll say it's been used in part 2. I hope it's not too confusing. I know it's like a lot of word juggling, but hopefully these are self-explanatory. If I make drawings, it'll just link them here, so you don't have to like look for them. It's all attached to this version history. You can also view things on the web. It's pretty nice. This is also how you go to the web viewer. You can upload things, so if you download STL files or model assemblies, you can just upload them directly to here. Select them from your downloads folder, and you can just convert them. People is once you invite people to your projects, it'll show you the list of people that have access to this folder. Top left, it shows who is currently in the file. Since Fusion is a cloud thing, it's collaborative. Therefore, it can be a little bit annoying having to wait for others to finish up editing a file. However, it could also be nice to know that someone else is on the file working on it, or you can tell them, hey, I'm going to work on this, please, can you get off of it so I can actually start editing it, because you don't want to have conflicts. Okay, let's YouTube here. This is the browser. I also like to call it the hierarchy because things drop down in a hierarchy fashion with the parents and the children. Comments, that's a bit more team collaborative things, so don't worry about that one. Let's start off with how to get started. So let's start with a sketch. If you hover above any of these icons, you'll get a little description and image of what it is used for. It's really kind of useful, and it's really kind of like intuitive how they have explained things, at least when I started. So this really helped me when I got started off. It's just being able to see these pictures and be like, oh, okay, so it's taking that blue area and they're rotating around that green line so that they can get that 360 degrees rotation and make that solid object from that two-dimensional slice. Same thing here with extrude. You take that two-dimensional slice and you pull it or cut away things, and those are called operations, and I'll show you guys that soon. However, let's talk about the 3 major kind of types of objects you can make in Fusion. There's objects, there's components, there's assemblies, there's components, and there's bodies. In other programs, you'll also hear assemblies, parts, and assemblies and parts. And within them, I'm pretty sure they also have bodies. So body is any kind of solid object, and it can't be something touching. So like, for example, if I just make a object here, like a rectangle and another rectangle, this would be, if I pull these into 3D space, we have a body and a body because they're not touching. So I have body 1 and body 2. However, they are part of the component 1. So let's say I was trying to make some chopsticks. These are definitely not chopsticks, but we're just going to go with that idea. I have my 2 chopsticks. They together are it's a set of chopsticks, which is one object or one component. So if I want to put the chopsticks in a bowl, I would have to make another component. So to make another component, I come up here to under assembly, I'll make another component in the bowl. Notice that the first part is still the parent. So if I close this, it's the parent of the entire thing. So just know that the bodies should also become a new component so that it's well organized. So I can make those components. I want to call this a chopstick, so double click to edit. So I'll call this chopstick. And since I made them both components, I want to pull this body into this body folder. So just drag and drop. I'll remove this. There's a delete and remove. Remove is a gentle way of telling Fusion, hey, in the history, mark that I took this out intentionally. Delete is just like hide it. don't let anyone know I even had it here. So I like to use remove because it prevents any issues. Like there's like a lot of issues that can arise with deleting things, especially in complex, large scale assemblies or files. So just know that bodies make up components, and components together, grouped up components like a bowl and chopsticks, can make up, you know, assemblies. So I would name this something more relevant, like a meal. You know, well, obviously there's no food in here, but I think it gets the point across, is that bodies make up components. Components together make up the assemblies, and they're all denoted by some special symbol. So 3 blocks here represent assembly. So it's a group of components, 3 blocks. These blocks here are the components. They're singular block. Within them, there's these like cylinders, which also represent, you know, components, but they're bodies that make up that component. So if I grab the chopsticks, I can move them. However, they stay fixed relative to each other. I cannot separate them, and that's what bodies are. Is that like they can help make something look correct. However, they cannot be jointed, or they cannot move relative to one another. So it's like a t-shirt. You know, a t-shirt is made up of threads. The strands of the t-shirt don't randomly, like, you know, readjust. Like they don't just randomly vanish out of thin air and pop into another place. That'd be ridiculous. They always just stay relative to one another. Maybe they're weaved together. So that's how you can think about bodies. A t-shirt would be the component name, and then a bunch of t-shirts together could make a rack of t-shirts, or a wardrobe of t-shirts, especially if you name let's say, a component wardrobe, and put that within, if you put chopsticks within the wardrobe, let's just say wardrobe. I don't know. And you pull the chopsticks into here, you'll notice that this will become an assembly from a component. Right now it's asking me if I want to capture or revert current positions. Parametric modeling is highly spatially related. So things that occur in one instance time frame, if you move them, like I kind of moved them trying to illustrate, you know, chopsticks sticking together, then it's lost that kind of parametric part. So I can revert it, so it's in the original position that I had it before I moved it like that. And you can see the 2 buttons here. Capture the new position, so this would make a new, you know, snapshot to start taking updates in the timeline from, or revert it to the last position, so everything's in the same reference frame. Notice that the wardrobe now is a assembly within assembly, so you can have a pretty large assembly with assemblies inside of it. Okay, so this is not the best example of how to actually go about modeling. It's just more of like understanding what goes into modeling, the different parts. You can click on the view cube to orientate yourself to a corner. This is usually called isometric view. This is a orthographic view because it's orthogonal, so perpendicular to the viewpoint. You can flip to the top and stuff like that. XYZs are labeled, so if I want to extrude in the positive direction, if I want to pull in this direction, like if I want to pull this block thicker, notice it's a positive number in the X direction. So then if I type in a negative number, it goes in the opposite direction. However, if you look closely, there's a bit of a weird thing happening. We have matter intersecting with matter, and that's impossible. In the CAD world, it's possible, but it's not good practice. It's really bad. So usually you just reselect from here and extrude that much rather than, you know, intersecting 2 pieces. The next thing I want to say is with extrusions, that's your main primary tool of creating things. If you want to pull things, you know, up or down and stuff like that, you can with the extrude button right here. I have mine bound to shortcut to the shortcut E on the keyboard, as you can see in the parentheses there at the top of the description. Notice that there's these bubbles. It's to activate a component. So right now, if I click on like this object, it'll highlight what that component is associated to, chopsticks. It's not activated, so all the timeline changes are being associated to this color of, I don't know, beige. So if I want to edit the chopsticks, I should activate this component and edit directly. And if I edit now, if I extrude now, watch what happens if I try to extrude down. It's because this is intrinsic to what's inside the body. So if I'm inside the parent of the bodies, it'll know I want to directly edit the bodies. The red means that it's going to erase this. And it's the same idea of extruding. You can extrude matter into the world, or you can extrude it out of the world. That's one thing I like about Fusion and SolidWorks is like there's not two buttons to distinguish the operation, but there's a bunch of operations listed here. If I want to join things, this would just be like, I want this to be seamless. This new extension of 25 units up is to be seamless. If I say new body, there's a cut. There's a little object here. They're touching, however, since I said I want them to be separated, to be just kind of a new body, not joined, it's going to make that cut. Kind of instancing that they aren't joined, they aren't actually like glued together. They're just positioned right on top of each other. It's like the threads of a t-shirt. If you double click quickly in the timeline, you can edit back that operation. Everything is, the icons are labeled to match up with the icons up here in the ribbon, so that you can be like, you can kind of look at someone's timeline and be like, oh, okay, so they made a sketch, so you see the sketch symbol, then they close the sketch after they made all the, you know, the two-dimensional lines and stuff like that, and closed areas to actually be able to select it, and they pulled it into three-dimensional space with extrude, or they revolved it. These are all things that take your two-dimensional stuff into 3D space. If I go ahead and double click on, if I go to sketches and I just, hold on, let me close this. I'm not in this the interface anymore. But if I go to sketch and I just double click quickly, I can edit that, and notice that I can update this. I can put dimensions, so D for dimensions, and this is your main power tool. So let's say 70 by 20, and then we'll also make this 20 by 70. And you can just drag this around. Once it's fully dimensioned, everything should turn black. However, they're not black or fully dimensioned just because right now I can move them in 3D space. They're not fixed in any relative position. So if I now want to lock it down for sure, I can dimension this to here, the origin point. Let's say 10. I want this one to also be 10. And then I want, this is blue because I can actually still move it up and down. So I want to lock this edge to this, and I'll say 30. I'll lock this one, this bubble, to 30. There's many ways to CAD. Just keep that in mind. This might not be the most optimal. I'm just showing you this way because it's easier and less complicated. In the future, you'll learn things about like symmetry tools, like mirror tools, construction lines, different rectangles, ellipses, and splines. Splines are really complicated. However, there's a way to master them that is pretty simple. It takes a bit of restraint. So when I'm done and happy with this, I can say finish sketch, and it'll update everything. So notice that these are perfectly even when before they were not exactly the same shape. Now they're exactly the same shape. If I want to know where they are with respect to the origin, you can see that they match up to my origin point being 30 millimeters up, 10 millimeters to the left, 70 by 20. And then I also added this little bit here, 25. So that's what parametric modeling is. Even though I changed the shape of this, it automatically updated so it matches it like just like before. Okay, so let me go ahead and activate chopsticks so I'm editing this directly. And let's see here. I think we can cover a couple more things. Modify tool has a lot of things in it. These are more of the complex things. However, these are some of my favorite tools to use. These won't be covered right now, but if you're curious, you can play around with them. Fillets and chamfers. These are kind of things that make your design look cool, and they should only be applied at the very end once you're done. So I'm not done, or nearly as done, and I'd like to come here and make this a little bit more thin. So what I can do is I can come here onto this face. So there's faces. The objects have faces. There's a bottom face, front face, side face. Or to be technical, I can say right. Actually, this would technically be the right side. That would be the back, and that would be the left. So whenever you start modeling and you have this option of picking one of these planes to start off with, it's always best to start off with the front view. The front view should always have the most amount of information. Right now this is poorly done. I should have this being the front view, as it would display the most amount of information versus this. It would hide an entire object behind it. Top view should you know, and bottom view should be pretty kind of self-explanatory. Yeah, that's the word. And let's say I'm not happy with the shape of this. I can come here and put a sketch on here. When I put a sketch on here, I can click on the corners, it recognizes. However, sometimes it won't recognize it, and sometimes we have to use a projection. A projection is if you had to kind of look at it from this orientation. Like, let's say I want to project this face. Then it would put me straight on, directly head on to this face right here. Be careful, when I rotate it, it actually changed the direction. So this is the same one. I would have to project it so that those edges are shown up and I can reference them. So if I go to create, project, /include, project, I can click on the entire face to set all the edges, or I can click on specified entities to be like, I want this one, I want that corner, I want this corner, and those are the 3 things I want. That line, that dot, the dot. If I click on bodies, it'll take the entire object. So if I had a staircase, then it would only show the highest point. If I had a staircase like stepping down like this, I projected like that, let's say top of the staircase, maybe each of the lines represent the stairs, and then just a profile, so I can't get any depth information. So I'm just going to click on this corner and that corner, and that's all I technically need. From here, I can get the other 2 corners from getting perpendicular lines, and I want to make chopsticks, so I'm going to make these a little bit more circular. So notice here that I can't snap it to the middle. However, down here I can, just because when I clicked sketch, I started off this one, so it actually collected more information than what we have up here. It collected the lines here, those 4 lines. I don't have those 4 lines like explicitly projected, so therefore it can't snap onto there easily as it can here. The triangle represents the midpoint, and all the constraints, I would highly recommend playing around with these constraints, because these are the foundational points of CADing. Without these, your CAD model will probably fail. Understanding these will help manipulate and also design optimally and quickly. For example, if I made a line, it's not parallel, and that's not parallel at all. Let's say I wanted this line to always stay at the same height as that one. I know it's horizontal, so now I can't move up and down. So it's just knowing that these symbols represent certain things will be very useful. Coincident means that they have to hit, like a point has to always stay touching to one line. So right here, this is coincident. The symbols kind of look a little different, so just be careful. Tangency, it's just that a line should be tangent to the circle surface. Equal, it's pretty equal. It just means that this should be the same length. So now if I change those lengths, they should always stay the same length. Perpendicular, if I want to say this one should always stay perpendicular. Now we're getting some places. Fix and unfix. This is more of like a don't use unless you really have to, because when you do this, you basically say you can't change the shape of this at all, and that's a problem sometimes because that's not good CAD practices. That's like cheating. It's like hard coding and coding. It's like hard coding. Midpoint is just like I want this to touch something in the middle. So like if I put a line here, I want this point to touch that point in the midpoint, so it then connects directly to the middle. Concentric is for circular objects, so if I put like a circle, let's say I put a circle here, I put another circle here, I want these circles to be like on top of each other so that they're perfectly centered. That's concentric. So I can click on these 2 objects. I hold down shift, by the way, to select multiple entities, and you can drag them together. I think if I click on these 2 edges here, concentric, just makes them lock together. I can still change the lengths and stuff. It just means that the center points always stick together. Coincident that to this line, or I can put it to the midpoint. I'm going to say coincident, so then I can specify where I want it along that line. Notice that sometimes Fusion 360 likes to automatically put automatic constraints. So right here underneath that circle is a triangle, if you look really closely. That's the midpoint, as we just talked about. I don't want it to be snapped in the middle, so I'm going to go ahead and click on that shaded triangle. It's now blue, meaning that I selected it, and push the delete button. I've just now mastered one thing, which is controlling my constraints. This is really useful to know what each of these symbols are, so you can immediately know that's locked to the middle. This one means that these two circles are locked together. This is perpendicular, that's parallel. I mean, not parallel, equal. So this always stays the same length to each other. This always has to stay horizontal. If I drag it over the center point here, and I say coincident, then it's always locked to the origin point. And I deleted the midpoint because technically the midpoint is right here. However, I don't want it there because I want it here. And let's say I want to dimension this to be specific distance away from like this point. This is also something to be aware of. Dimensioning, you can do it horizontally, or you can do it kind of in line with the actual dimension. So I'm going to do it in line, and I want this to be 15, and I want this circle to have a diameter of 15, and I want this outer diameter to have another diameter, the distance from those two I want to be 5. Now this is all locked together. This is moving because it can still stretch along this line, so we'll limit this line's motion, and I don't want it like this or else it can possibly rotate. So if I just type a number, I think I should be able to make it angle. So you see it stays that length, however it changes angle, which is not what I wanted. So I'm gonna delete, I'm just gonna delete this, make a new constraint. I'm hitting D for dimension, click here and gently place it when it's angled like this to signify it's always gonna stay parallel. So if I say 50, no matter how much I manipulate it, should not be able to rotate because it's stuck at 50 unless I change this angle. So you can see it's changing the angle because it's forcing that relationship to be perpendicular. This is a nice kind of pivot point, so I'm going to keep that. It's kind of cool to play around with. I'm going to now dimension from here to the origin point. I'm going to try getting a horizontal. I got horizontal. Just be careful where you place it, because it also dimensions like how it's laid out when you're first placing it. So I'm going to say 0.5, and then I want this to come out from this point, 0.25. Oh, maybe that's really small. I'll come here, double click, edit. I'll say 2. Okay, that's good. So it's completely black, meaning that since I dimensioned it to be a triangle, it can't technically change its angle because it's defined by these two dimensions. You know, you got the adjacent and the opposite. Therefore, the hypotenuse is determined, and you have the angle because of its tangent. If you do tan of opposite of hypotenuse, you got the angle. Therefore, you know, you only need those to determine the angle, and therefore I can't change even the length. That's fully dimensioned. Now let's talk about the angle between here and here, and I'll say 120. Now notice how much it got. Notice how many things turned black. This turned black because they have to be equal to that hypotenuse. So those are constrained. This has to be perpendicular. We dimensioned how long this is. This pivot point is being a bit weird now, so we're going to go ahead and lock it down. I'm going to make a line from here to here. I say I'll make this like 57. Oh, I must have typed something wrong. Double click. Uh-oh. Control Z. 25. Let's see what that looks like. Okay, that's interesting. So let's see what happens. Okay, so, oh, that's really strange. It's like a robotic linkage now. So at this point, hopefully you're getting a bit of understanding of the constraint tools. These regions here that are enclosed are areas that I can now pull into 3-dimensional space. Over here, I can't click it because, you know, it's not looped in. So therefore it's infinite space, and it's definitely not gonna, that's definitely not how SolidWorks or CAD works. You have to be able to make a closed region, and then from there you can pull into 3-dimensional space by extruding or pulling. So that's a bit of sketching. So let's say I finished, and I'll just pull this part down. And operation type, I want it to be a new body because it's not touching those bodies. Otherwise, I could join them to make it seamless. Here, it's not seamless because I made a new body compared to this body up here, which is body 2 to body 3. You can see the bodies here. You can also click here once I'm not in this extrude tab. So let's finish up the extrude. There's a lot of different operations. New body makes that. Join makes it seamless. Cut, like deletes things away. Intersect is that if I took this object and I like cut it through that one, whatever is left, whatever is intersecting at that point will be kept. Everything else will be deleted. new component makes a new component. So let's say make a new component and notice that it's nested within the chopsticks. So I don't know what this would be, but yeah, it could be splinter. So chopsticks, the splinter is within the chopsticks. So that technically, this is a bad example because chopsticks don't have splinters floating in midair like this. If there were any, it'd be like here and they would fall apart. So therefore, that's one way you can organize things, is like things that don't technically have glue sticking them, but they can fall apart. But they still are intrinsic to what the object is, which is like this is made out of wood. It's supposed to be one piece, but it could be made up of extra detail. However much detail, that's up to you. So come back in again, double click this, and we have our sketch. I think that's good enough for the first video, so I'm gonna wrap things up and I'm gonna give you guys a challenge. I want you guys to make some better chopsticks than I can. Try using the front plane correctly so that the front has both of the chopsticks side by side. Try using more of the circles and feel free to make it as detailed as you want. Proportions don't matter, just kind of make it look like. You can get a ruler beside you. This is also good practice, just have a ruler, because whenever you can, things get microscopic. And we want to avoid that because sometimes they'll be impossible to make. So I'm going to give you guys some dimensions. I'm also going to quickly demonstrate how I would make them so that you guys have to make a new way that isn't obvious. Isn't that fun? So I'm going to use circles. I'm also going to use a bit more advanced sketching techniques. I'm going to use construction lines, put a line from the center down. Notice that there's an icon that looks like a sharp, it looks like this icon, meaning vertical. This is vertical, so I cannot change the angle anymore. This is perfectly fine because I can use that to mirror over that line once I'm happy with this shape. You guys can use cylinders. Actually, I'll make mine a little bit complicated so that you guys have something to make. This construction line, turn that off. Default construction, turn that off. From here, I'll make a curved line by clicking and dragging again. Another line, clicking and dragging. Oh, line is L, clicking and dragging, letting go. I want this point and this point to stay horizontal, vertical. I want these points to stay horizontal to each other. This one to here, to this point, stay horizontal. I want these guys to be equal. I want, this is a little confusing, let's see here. I want these points to be coincident. I want those points to be coincident. And now I can, I can now specify the width with dimension. I'll say 5. And then I'll change the radius of this one to 5. And then this one should be locked to 5 because geometrically it shouldn't be able to move. And I should be able to move this, that's why it's blue. Now if I say I want this corner and that part to be 36, and I got it dimension this way, so 15. Now it's completely constrained. This is what you want in parametric modeling, completely constrained objects. So that way everything can update as you go. So if I come in here later to 10, everything should be fine down the line with whatever you do. Now let me double click this to select the entire length, like whatever's touching adjacently, it can just complete the loop. I'll go to the mirror tool. I have my objects. I can also click on the dots here if I want to be fancy, and click on over this line. Now I have my 2 sets of chopsticks. These represent that it's been mirrored. The mirror should be captured somewhere. I believe there should be an icon in this sea of icons here somewhere. It should look like this, the triangles. However, we'll keep going. Maybe this one. Nope. Okay. So I have my 2 objects here. I'll just pull them into 3-dimensional space. I can also say 2 sides extrusion. The directions, I can pull it in one direction, like up or down, or I can say I want 2 sliders, so I can pull one down and one up, so I can make it asymmetric, or I can pull them in different directions, certain lines. When I click on this arrow, I'm directly editing here, so I can just click on this to say go to that height, so these should be equal. And if I click on here, I can say go to that height, so that should be equal. Now I want this to be a new component because these are my better chopsticks. And okay, I'll name this double click better chopsticks. And then I'm also gonna teach you guys that if you want to pull things out, you just drag and drop them. Notice that this is not nested with inside the wardrobe because that wouldn't make sense. So we have our chopsticks now here. It's grayed out because I'm actually activated in the the child component. So I'll just clean this up. Splinters. You can also hide things with this eyeball. I'm gonna activate the parent, and this kind of like just shows you everything. Origin, you can turn this back off. Visibility there. And now I have my chopsticks here. Okay, and the last thing, just so that it's more fun to play around with on your own, is changing the appearance. Hit A for appearance. From here, you have like a lot of options to make things look pretty. I like to use the wood textures. Let's say just put cherry on here and cherry on here. Now that does not look correct, so double click this and I'll change the scale. And now we have some pretty nice looking chopsticks. And next time we'll make these look even better. But for now, I want you guys to come up with chopsticks and follow the same kind of ideas of how to go about making a sketch, pulling into 3D, and from there we'll talk about drawings next time.